Yeah, so when we set up our pipeline, there wasn't very many of us that actually knew Kubernetes very well. But one of the requests that came from management is that they wanted something that was more agile, something maybe microservices, something that was easy to deploy. And one of the things that I had thought through in the past was the kind of weight of, this is how it gets configured on my machine, therefore, I know how it works, and then you go to put it onto a server and, oh, everything goes haywire because of all these little dependencies you didn't document, right? So the whole container world seemed to make sense to me, and then Kubernetes as a way to orchestrate that seemed to make sense. So this was kind of us breaking into it. So letting you know what I'll be talking about. I usually keep my stuff really zoomed in because I'm blind, but so this is the agenda that I'll be talking through. Kind of the principles that we worked through and what we used to kind of guide decisions. A little bit of a history about the team and the company and the challenges that we had. The approach that we started taking, and a little bit of the trade-offs that we encountered. And then the architecture kind of generally of how things were flowing through the system, so it may give kind of an easier frame of what we were working with. And then some of the different pieces of what I'm referring to as the pipeline here, the iteration pipeline, so that we have the build policy and then the builds, or the PR policy and then the builds. And then I'll work through a demo of what some of our builds look like. And I got permission from the managers to just show the stuff that's right, actually the stuff that we're using, and talk through some of those things. And so other than like peeling back the credentials and showing you all our passwords or any of that kind of stuff, I can kind of talk through and show these things. And then kind of talk through also how that transitions from builds into releases, because just because it builds doesn't mean a whole lot until it actually gets out and people start using it, right? And then at the end, I figured we'd have some time for kind of more in-depth questions, hopefully. All right, so one of the core principles that I wanted to get across is that failure is normal, right? A lot of people like to think that, oh, the only time I can check in code is when it's working perfectly, right? And so you can end up with some people, they're sitting there working, a week later, 2 weeks later, still working on it because they're trying to get rid of every single bug and every single mistake, and every time you talk to them, they're talking about refactoring something or fixing a bug, right? But the reason is, this is what they think of when they're thinking about failure. This is the problem that they're trying to avoid. And the reality is that if you can make failures look more like this, then that's fine. This is more approachable, right? Like, oh, it didn't come together the way I thought. And then you make that cheap. And so cheap failures was one of the core principles that I wanted to try to get us to build our pipeline around. This idea that failures shouldn't be something that's a culmination of 2 weeks of work and then you fail. No, you need to fail a lot sooner, and if you can, make that a few minutes. And if you can't make that a few minutes, how can you make that an hour? And just how can you push that envelope down as small as you can, right? And so this was the kind of one of the principles that we used. The other thing is that I personally enjoy moving fast. I keep asking, how can we move faster? And I find fast fun. And so when I think of fast, I think of this kind of a fast. Like, I can't get enough. And I was talking with my manager one time, and I sound like a discontent sometimes. He points out all the progress that we've made, and I say, yes, but I want to go faster. It's like, well, so this strategy was about kind of trying to incorporate some of those ideas. How can we keep going faster? I also think of doing repetitive things as being extremely boring. This person epitomizes my thought of doing the same job over and over again all day long. And this is something I want to make sure that my job and the guy who works next to me does not have to do. If you are doing exactly the same work every day in and day out, we're doing something wrong. The computer should be doing almost all the work. And if we can make that happen, we're on our way. So the great thing about working in software is that we don't like to be right once, right? So if you think about, what's up?
Just wondered, do you want questions during your talk or not, or
If I'm going too
at the end?
fast and you don't understand me, yeah.
Well, the one point you just made is I think that there are different kinds of jobs, and so sometimes spending time on doing the type of job that you're doing, if it's research or whatever, then you might have to invest more time in it.
If
And-
you research the
but you-
same thing
you-
every day,
You
then
might
you're doing the wrong thing.
Well, I'm just saying that you might not be able to automate some of the things that are experimental in development.
Maybe. We can push the boundaries on some of those. So the other thing about software, we only have to be right once, right? So once we get it right, the software is designed to keep replaying that strategy or that formula, much like someone who is doing a bakery, right? The success of doing a bakery is basically doing the same recipe that was the winning recipe the first time, doing it the second time, right? And just repetition of the same thing is what we want, but we don't want to be doing it. We want the computer to do it. And once we get that formula right, we can give it to the computer and let it continue. And so, this is an example of what I think of, it's like, they had so many failures trying to make their airplane work, but once they got one version of it work, they knew that they were onto something and then they could build on it. So, the last thing I wanted is, and this will kind of blend into a little bit when I talk about the company history that we came from. There was a lot of legacy software. And one of the things I've seen a lot of places do is they decide from a position of fear. And deciding from a position of fear is the wrong thing to do. If you come into a situation and people say, we can't do it because we don't know something. We can't do it because, and then they talk about all of these reasons why they can't do something, and it's because they have fear. But you want to decide from power. Power is, you go and get the knowledge. You say, well, I don't know enough, but I can get a list of people who will sign off. I don't know what the requirements are, but I know the people who have them. Decide what it is that you need, and then go and get it, and then decide what to do. But don't ever decide from fear. And one of the things that we had a problem with in the past is that so much of the software actually, because of different people leaving and different things like that, people were afraid to touch it at all. And that's a very bad proposition for us to be in. And so something I wanted to help use the pipeline as a mechanism to help get rid of. And so when you think of someone who is like this and you see what he's doing, I'm sure he's not afraid that he won't be able to lift that weight to the amount that he wants. He came in, he knew what he could do, and eventually when he fails, he comes back in tomorrow and he knows what his number is that he's trying to hit. And then he's going to use that as a metric to change. This man probably spends every ounce of his power thinking about how to make the right decisions about his nutrition, about what he's going to do tomorrow for his workout plan, all of it, right? And this is an example of someone who's exercising that kind of discipline to always decide from power. And so hopefully, maybe I'm not going to look as buff as him. Hopefully I can get similar results, but maybe through the software. So a little bit of a history of the code. So the code base that I came into when I joined this group, this company had zero automation, zero. They had no unit tests at all. When I said that they had no unit tests, someone said, no, I have some unit tests. The unit test that he was talking about uses a file on his desktop that's coded to his username. And he hits the thing and runs, and the test only proved that it could run to the end without an error. That was his unit test, right? And so, from my point of view, there was no unit test, right? There was no build automation. The code repository, when you pulled it down, it couldn't build. Like, you couldn't pull it down. It didn't build at all. Why didn't it build? It was like all these permission problems, all this different stuff. Binaries missing, like all kinds of chaos. So the code was in really bad shape when I came. And not only did they not have their code in order or build, they didn't have their deployments in order. Their deployments were basically, I come to work and this is the day of the deployment. actually, I'm sorry, the deployments were so bad, they could only feel comfortable doing them on Sunday. They would do them on Sunday night. And it's because they didn't want to impact the users. And so they would do them at night. They had accumulated what they thought was everything that they needed to do. The machines actually had a mix of both like dev code on it and production code, both running on the same machines. They'd be pushed there manually. They'd zip up the files that were published and put them over there, and then like have to open up the zip file and like delete parts of it before they copy over. Like it was chaos. I kid you not. I took notes of what the deployment process was. The guy talked a million miles a minute. I think it was because he didn't want me to actually understand. But it was like this long of steps that were all being done by hand, and a lot of them were conditional. So you had to make decisions at different points. I don't know about you, but Sunday night is not the time I want to be deciding how I'm supposed to be doing deployments and trying to figure things out so that I can untangle the chaos that happens. And on top of that, all of their production database deployments were all happening by some note file that they would open up and then say, oh, change this stored procedure to be this one that's over here, and change this file, like this other function to be like this. It really was chaos. And then from a process point of view, they didn't have any pull request process. Code comments had very little compliance. Just like overall, the entire process was just really in chaos. And so I mentioned a little bit about how I wanted cheap failures. And for me is if I get down to the bottom and I can't successfully get my thing deployed, that might be a failure, right? And so having a cheap iteration loop is kind of just a continuation of that cheap failure idea. For me, an iteration loop looks like code, build and test. I can do it locally. Build and test, an agent can do it for me. And then I can do a pull request to get feedback from the other development staff. And then I can do a deploy. And so for me, this is what an iteration loop looks like. If you have a member on the team who can't do all of these steps, they are unable to iterate. And to me, this was kind of the minimum unit of what it means to contribute on the team. The other thing that we did is we said that comprehension was more important than completeness. And the reason why we did this is that we felt that you will always have requirements for more things that the business would like you to do, or more edge cases, or more situations. And so rather than trying to be fully complete at the start, it needs to be easy for the next person to understand if that person's not you, or if it's you coming back to it, you need to be able to get back in and change it easily and understand what you did. That's the most important. The other thing is that being able to do more attempts at iterating was better than trying to be complete all in one shot. So the folks that would say, I'm going to do my application, I'm going to check it all in one commit, like that's totally the wrong thing, even if it works. And the reason is we need to have small chunks and small iterations. All right, so a quick view of what the architecture kind of looked like. So in this view, I kind of think of the peach colors as kind of, I don't know, the data that kind of supplements or kind of complements our process, or as kind of the evidence of work. And so here we have the Git repositories for the different projects that we're working on. And that flows into the build agents, and we have the build automation. And so the build agents are responsible for taking that code and more or less doing what your onboarding process should be if you had a brand new person who came in and they said, well, how do I even get started with this project, right? You would say, well, download the code, and then do a build looks like this, and then if you have some tests, this is how you're supposed to exercise the test. Hopefully you have tests. And then this is how you can start to make changes, right, and exercise the app. And so that's kind of what the build automation is supposed to help us to do. Then we have the build artifacts. The build artifacts come out of the build automation. They should be the containers and the packages and the deployment definitions. And so what I mean by deployment definitions is in our particular org we were using Helm. And so we the Helm packages that would come out were part of our build artifacts. And then we had deployment agents. The deployment agents for us are very similar to the build agents, except they're responsible for the stage of taking the build artifacts that came out from the step above and pushed it into the Kubernetes cluster down below. And so we are working on refining this process, but basically we use what in the build process pipeline that we're using, they refer to these as stages. And so each one of these stages is a horizontal pipeline. So you can say it doesn't get to the next stage until it finishes being deployed to the previous stage. All right, so, if any of you want the slides, I put it on my GitHub, so I put it here. But the reason why I put this message here is if you click the link, it's only going to work for me because I can log in. I want you to think, what is this guy doing? Okay. So the first thing I wanted to show is, I wanted to show a little bit about what I meant by the PR policy, the branches. And so we only bothered to put policies on the master branch. At our particular organization, we felt that it was better to have a faster iteration, so we wanted to reduce barriers in getting into the main line. And what we wanted to do is that if there's a reason why your code shouldn't come in, it should be part of the policy. And so when the projects first start out, we started out with very simple policies. You have to have at least one other person review it, and then mark the approve button. You need to check for linked work items, and so these are just basically the cards in the tracking system that just says, well, why are you doing this work at all? You need to have all your comments resolved, so if someone put a note on part of your code or part of your pull request, that you just have to acknowledge it. More or less just a checkbox that says that I acknowledge that this is done. It's not real complicated. And then we have the builds that are required to run. And so here, we basically, there's different ways that this particular tool, and if you're not familiar with this tool, it's Azure DevOps. So Azure DevOps is a Microsoft product. It combines work items. It combines the kind of like the team dynamic to manage the work items, the source control management, the build management, package management, and then release management. So kind of like all in one umbrella. So very typical of Microsoft. Like if you look at Office, this is like an example of kind of thing that they like. So in this world, and there's probably better tools out there, and if you find some and you like them, don't just use this one because I use it. Use what's good for you. But we did strict expiration. The default of this tool was to do a timed expiration. So the strict expiration just says as soon as someone changes the code, it's got to build again. Our builds happen to be fast enough. We pushed for builds that would happen in usually about like the 5-minute range or so. And we have a few builds that are a little longer than that, but not very many. But all of these builds can run in parallel as long as there's different build agents to ship the jobs to. So the other thing that we tried not to optimize was the computer's time. So if this build has to redo some of the work from this build, who cares? Like, let the computer do more work, I don't care, as long as I have less work. I can buy more computers a lot cheaper than I can clone myself. So but these were some of the builds that we required. One of the builds here is we had clients for this particular service. This was just the normal CI build that would emit the containers. And then this was contracts. And so this was basically just a package that contained some of the models and shapes that we were using and allowed people to download that as a package. All right, so that was what we had as our pull request policy. And so getting a chance to see some pull requests actually happened. This is just reminding me that I can send something in for a pull request. All right. So here's one that ended up getting approved and completed. But, so, you know, folks just come in here, leave their notes, mark comments on the different things, and then every time they do, you just have to mark that the comment is resolved. So it's pretty basic stuff. If anything doesn't work, you'll see the red marks over here, and it'll stop you from continuing. All right, so build terminology. I thought it might be helpful for some folks if you're not comfortable with the terminology of builds to just go through them quickly. So I think of a build as being the process of getting someone or something to work through the steps to have evidence that your application actually exists and that the work was done. And so this build will end up having a definition. And so the definition is just basically what is the steps to perform, the variables. So whatever variables go into the builds to, like, is it release mode, debug mode, different things like that. And then different triggers. So why would you do the build? So in the case that you bring a person in, you might have that person come in and then they would do the steps. But let's say labor was super cheap. You might say, okay, well, someone changed the program. Start over, like, you know, erase it from your computer and then do all the steps again, right? And then agents are kind of the machines or the actors that are performing these steps. In the case of really cheap human labor, that would be a person. In the case of a computerized world, it would be the computer, obviously. A build controller is the machine or the process of just spreading out who is supposed to be doing what build. You know, how do I distribute the work? And then the artifacts are just the evidence of any particular stage being completed. All right. So here's a demo. All right, so in this screen, we get a list of all the builds that we have available in our process here. This one is recent builds. This one is kind of like a list of all the builds, but kind of building on what I showed you a moment ago. This one's a recent one that completed successfully. And so we'll just open one and hit edit. In our particular organization, we made a shift to YAML builds. And so if you're not familiar with YAML builds are basically this idea that you would describe your build in some sort of a descriptive format. This was a huge break from the way Microsoft had done it before. Microsoft previously had you define the builds in kind of this web page where you go in there and define all the steps that you needed to do and all the field markers that you needed in here. And unfortunately, what would happen is, let's say, oh, I need to dramatically change what it means to do a build, but in order for me to do that, it's going to break builds for other people, right? So then you would have this awkward process of how do I upgrade the build to support what the new software looks like, and how do I not break other people who are still working in that software now, right? And so YAML builds helps to do that because you save it in with your code. And so this is, for our process, we kept it simple, so these files were just saved at the root of the files, of the project files. And so here we just had different steps that we decided were important, and over time we built this out. So one example is this particular step didn't previously exist. It actually seemed to work out of the box. And so the build agent already had this tool on there and had a sufficient version of the SDK that the early versions of the project just worked. And so later, as we started to work through the process, different versions of the product ended up coming out requiring different SDK versions, and then we added this step to ensure that the build agent would have the proper SDK. And so as you work through each different step of the build, each different step just defines a task that's in their system and helps you to perform that step. You can think of it as like a little mini like bash script with a bunch of environment variables that have already been defined, and it runs this step for in that sequence. All right, so I'll show you real quick. when we go to manage them though, one of the things that we found is that it was not super helpful typing in that YAML. I don't know about you, but I hate having to look stuff up in the documentation like some guy who's trying to translate between English and Spanish, and I just don't speak the language that well, and every time I turn around there's a word that I just don't know, and I have to hunt through the dictionary and the language book and figure out what it is. I much prefer typing in an editor that says, this is what you can type, right? And be kind of constrained toward the right answer. So one of the things that we would do, so we would create new builds and would say, okay, what is it that I'm trying to do? So we make a new build, we come in here, and we just start out with an empty one, and I just say an empty job. And usually the defaults are not that bad, right? You can define what agent pool you want. If you want a specific one, you can pick one. So like if I want one that's one of our private builds, I could choose a private build. And so these are just groups of machines that all can be considered the same. You can think of them as a team. So here we would just add a task, and I just come in here and say, okay, well, I'm going to do a .NET Core related build step. This is, I want to add this. And then when I come into it, I can define all of the arguments that I want. So let's say that I'm going to not build, I'm going to do a run. I'm going to run, a particular project maybe. You just fill out each one of these steps, and then once you get done, at the top where it says the agent job, you can say, I want to view this, and then it would show the steps. And so we use this kind of like naive way of doing the tool to kind of see the work that we would start with, and then once we had something close, we would put it in, and that would go into source control. Now later when there's a step that I want to do that I don't know the syntax for, I would just come in here, add that step, and then come in here and steal that step out of this description and put it into the other. And that's how we ended up iterating. There's probably better ways, but we just chose something that was simple. The cost of being wrong was very small because you just send it off to the build. Doesn't work, try it again. So in this process, we leverage variables, I think, quite a bit to try to help streamline some of these YAML files. So sometimes we'd end up with a recipe that worked reasonably well. And so increasing the use of variables made our stuff a lot easier to, I'm sure all of us have went to Stack Overflow and copied the answer to some question our boss had given us, copied that answer and pasted it right in and said like, I'm awesome because I can use Google and find answers on Stack Overflow, right? But by finding another developer who's already done what you wanted, you take that answer and you put it into your spot and solve it. Like that's what these variables helped us to answer that question. All right. All right, so some of the release terminology, and I just bring it up because I'm about to show you the release screen. So the releases are this process of you getting your application out so people can view it, right? So you think of if publishing is the process of taking data and making it more readily available. Releasing is getting that at each one of the newspaper stands, if you will, right? So it's like, what is the process to get it out there? Are there trucks to do the delivery? Do I have to bound up all the newspapers? What does it take? And this is kind of defining that process. Artifacts are the outputs, if you remember, from the build. So it's kind of the last item that I covered here. And those become inputs for the releases. The targets of each one of the releases are the stages. And then deployments is just the process of executing one of the sets of this recipe one time. So every time you've executed it once, there you go, that was a deployment. All right, so here are some of the releases that we have. And so we try to keep the releases pretty simple. So in our setup, we used Helm releases to try to do kind of a little bit better. At first, we actually just used just the Kubernetes deployment YAML. We had service YAML, and I think like that was pretty much it. We had like very naive. And then you would just say, kube control apply, right? And that works, sort of, but it got us kind of going. As we improved it and we said, we're going to use Helm releases, one of the things that we started doing is we found that not all the developers liked having the configuration of a release separate from what does it mean to define the project that it's meant to release. And so having two repos really put a lot of cognitive overhead on the developers, and so we ended up squashing that down. And so we just said the Helm releases build and the code is saved in with the same service, and I'll show that in a minute if that matters. But so the build from one of our services, and here this is a curation service, I want to take this build output, and I want that to become the input for this process. You still read it? All right. So I want to take that and make that the input, and it's going to do the latest from the build pipeline for the default branch. And so the default branch we had was just master. And so every time you would commit to master, it would basically create a new release. And so as we started to build out this pipeline and refine it, one of the things that will happen is that alpha will come first, and then beta will actually, in our group, be controlled by the QA, and then the pre-prod, and then prod. And each time there will be a process that gates it forward and helps us to get it done. Our pipeline, like I said, try to keep it super simple. In this particular tool set, one of the things that we found that helped us a lot, and I'll go back to the Helm definition that allowed this to work, but we used the release variables right in with the Helm definition so that we could set values very quickly and very easily. And so some of that is set here using these build steps. So this particular one would go through and take a bunch of the release variables and do a replacement on the files and help you to get the specific settings for that deployment into the deployment. Then it would take, make sure you have the right version of Helm. We would download the Helm charts that we had packaged during the build, and which version of it was actually defined by the build that was done. Because we built the Helm charts as part of the source code build, it was always a one-to-one correlation. So we just tried to make everything really simple. We would create the container registry secrets. This is just basically, we have a private Docker registry or container registry. In order to talk to it, this would just make sure that the secret was available here. And if you've done this stuff before, probably a lot of this stuff you're thinking, oh, I got like better ways to do it. This is just what made sense to just try to make progress. And then here we had secrets for the particular service, but because we made everything into a variable, we just dropped it right in. And so this would create the secrets for that pod or that deployment definition. It would put it right in. And we actually found that using config maps for us ended up being a bit a bad fit, and I'll get to that now. So here is when we would actually perform the upgrade stuff. We would just, basically do all the defaults with variables for each value that it's expecting, but with one thing changed, which was the wait. We found that asking Helm to wait until the deployment was finished helped us to know that the deployment was more likely to have been successful at the end. And so this was a huge for us. So if anybody's interested, I can show one example of what the Helm files look like. So in Helm, it seemed like there was a strong push to have Helm folders with the name of the service that you're trying to package up, to just make a folder with that name. A lot more things lined up. And so I mentioned that we had values that were getting replaced. And so this particular service doesn't have a lot. Let me show you one that is more. Yeah. So this one has a few more. But basically these were just values that were part of the release pipeline. We just set them as variables. And those variables, let me see. So those variables just show up here, and then you just go in there and just define your variables. On the right-hand side, it just says what's the scope of the variable. Is it for the whole release, or is it for a particular stage? And so those variables, because of one of the replacement steps, will end up replacing this. The reason why it's able to do that is that the release agent, one of the things it does is it pulls down the files that were part of that build archive. So that includes, for us, these files. And so when it does the replace, it's able to incorporate this file as part of the release pipeline. And so this file is available to us during the release, but with these values replaced for us. All right. And so one of the things that I took the trouble to do for our group is I went in and I did a full templatized version of the deployment YAML. And so everything ended up being variables that were just replaced. And so that meant that you were able to just take the same deployment, put it into the next service mostly, and just replace the variables, and there you go, right? Now, I have to tell you, when I first started doing this, one of the reasons why we weren't using Helm at first, the idea of learning this handlebar language, I was like, all of this, and I have to learn Go, and I have to learn, no. I was like, we're just going to do it the simple way. But it ended up being worth it to have some sort of templating answer. Whether Helm is the right answer for you, whether you want to use a different platform, not substantially my problem, it's yours, but I found it useful to have some sort of a templated answer. If you happen to want to use Helm, it's pretty simple. In these ones, the template are basically named functions, and then it copies that template into here, and this dot is just the scope of variables that are going to be passed in. These double handlebars are escapes to say I want to go into the templating language, and then the ones that you see with the little hyphens here, let's see here. So the little hyphens here inside of the handlebars basically just say, I want to delete all the white space to that side of the escapes. And so that's pretty important in this YAML language, because if you screw up the white space, this thing goes haywire. So one of the other things that if you get used to using Helm, the Helm is an option to say I want to print out what you would have done with these files so that I can see kind of what the output looks like. And that will help you to kind of debug things. But yeah, we did that. The services, actually the first version of our services we did very naively. We had no, we were just using node ports. We have someone helping us right now to set up a proper load balancer and all that stuff. So we have some folks coming in and all that stuff. So yeah, this is kind of what we did. This is what the release process looked like. Each time that you run a release, you get basically just a deployment. So this is an example of a release. And one example of a deployment is, for example, would this release run one time gave this deployment on this page. So I think I've used up most of the time that I have here. So if you have questions, feel free to see me after the talk, and I'll be glad to try to talk with you about whatever challenges you might be having as much as I'm able to. Thank you.
to look at, so help yourself.